In this video, oh, sorry, didn't mean to do that. In this video, I'm going to look at how you draw a ray diagram for spherical mirrors. This is not something I can easily do using the pen feature that I usually use when doing these videos. So instead I have an animated PowerPoint that I'm going to talk you through. So first off, we're going to start with a concave mirror. Here is the focal point. There is the radius of curvature or center of the circle, however you want. And we're putting the object way out here. Now, when working with mirrors, there are 3 rays. I have color-coded them so that you can follow it. And it's always the same 3 rays, though sometimes they look very different. The first ray, I'll do in red. It goes from the object. So notice it goes across the top of the object, but it's parallel to the axis. Once it hits the mirror, it reflects through F. The second ray goes in, it hits the top of the object and the focal point, and then once it hits the mirror, it turns and reflects out parallel. And the third ray goes across the top of the object, through the center of curvature, hits the mirror and reflects out back upon itself. Where the 3 outgoing rays cross is where your image is. So the image is right here in this diagram. Our object is here. The image is here. I would describe the image as real because it's in front of the mirror. It's inverted. This arrow points up while that one points down. And it is smaller. The object arrow is bigger than the image arrow. For the next ray diagram, we're going to move the object inward. So now it's between the center of curvature and the focal point. First ray goes parallel across the top of the object, hits the mirror, reflects, goes out through the focal point. Second ray goes in, hitting both the top of the object and the focal point, and then turns at the mirror and goes out parallel. And the last one goes through both the center of curvature and the top of the object, in and out upon itself. And where those 3 cross is the image. This image is real, it is inverted, and it is larger. For our last concave mirror ray diagram, we're moving the object in again, so now it's between the mirror and the focal point. Same 3 rays, in parallel, across the top of the object, turn and go out through the focal point. Ray 2 goes in, it hits both the focal point and the top of the object. Once it hits the mirror, it turns and goes out parallel. And the last one goes in and out, hitting both the center of curvature and the object. Now look at the 3 output rays. Here's one of them. The green is the second, and this red one down here is the third. Those do not meet in front of the mirror. Therefore, there is no real image. Thus, to find the image, we have to backtrack our output rays to the other side of the mirror. That looks like this. So here's the output red one, the output green one, and the output blue one. Where those 3 cross is our virtual image. It is virtual, it is upright, and it is larger. For the last ray diagram, we're going to deal with a convex mirror. Recall that convex mirrors only produce one type of image, therefore we only need to do 1 ray diagram. All of them will look the same. Our first ray comes in parallel to the axis and then reflects out through F. So there is a line that has to connect where it hits the mirror to the focal point. The second one comes in, hits the top of the object, and has to go through the focal point. So that's what this is trying to show us here. And then reflects out parallel. And the third one goes in, hits the top of the object, and also has to go through the center of curvature. Our 3 outgoing rays, here's the red one, there's the green one, and there's the blue one. do not cross in front of the mirror. They will cross behind the mirror, so I'm going to go look for the virtual rays again. To do so, we back up our 3 outgoing rays. There they are. As mentioned, the red one has to go out through the focal point. Here's the blue one, and there's the green one going through the center of curvature. They cross right here. So there is our image. It is virtual, upright, and smaller.